catch up on what we've been doing. So I think it's time to kick it off, right? Yeah, near enough. So thank you everyone for coming. It was a bit short notice this time around. We thought it was going to be held at Google. We thought there was going to be another topic, which is why we were holding off from updating the notice on the site. But we do appreciate you coming around at short notice, and I hope this is interesting for you and get something out of it. As we said, this is now a year that we've been doing these publicly. I think our first meetup was exactly August 2017. Yeah, just after we moved into this building. So we're doing this a year. We appreciate any feedback you got, good, bad. We want to hear it. And like I said before, if you've got a topic that you want to talk about, very happy to do it. And we'll work with you to try and keep it as secret-free as possible. Right? Nobody wants to spill the beans. So having said that, good, that's working. Today's talk is and demonstrations are all going to be about infrastructure as code and working with immutable architectures, immutable infrastructures. A little bit about me. I work here at Neudesic. I'm director of Google Platform. So everything to do with Google right now, whether it be for your company or any of our other clients, I'm involved in some form or another. I've been doing this in the cloud for about 10 years now, I think. Yeah, 10 years on AWS, and now focusing exclusively on Google for the past couple of years. All right, so immutable infrastructure. So what exactly is the problem that we're trying to solve here? One of the large issues, or probably the largest issue with mutable infrastructure, by that I mean things that change in place, right? One of the biggest problems is that it's fragile. We do an update on a VM, you make a change, something breaks, your system goes down. This is all bad stuff. So the idea of immutable infrastructure is to reverse that, is to make things set in stone, no more changes, and we replace rather than update, essentially. I'm getting ahead of myself here. Should have reviewed them a little bit better. So the idea again that we add new pieces when everything's tested and working well, then we remove them. But the idea is that nothing changes in that initial setup. What does that give us beyond just those safety nets? It gives a state that can be shared. So whether it be within a source control system, such as the configuration files, or whether it's the actual binary state that is representing your environment, that can also be shared in a GCS bucket or an AWS bucket or whatever it is. But there's a way right there for sharing it, because whichever instance it is, whatever data file we've got, that represents the declared state of the system. And if we make changes to it, there are going to be changes replicated in the environment such that it matches. Okay, so much like a database with transactions and everything else, there's one configuration that should be right at any given time once you reach that certain level of maturity. Excuse me. So when it comes to tools, especially on Google, there's really only two that are widely used. One is the native tool deployment manager. It's very capable. It's a little immature, but it is built in, it's free to use, and it has full access to everything that Google does. Right? Whenever they bring out a new product or a new platform solution, you know that deployment manager is going to look into it, probably before anything else. However, tool, it's certainly got its own bugs and issues, and it's when you configure in deployment manager, you're either writing in Python or Ginger templates or some combination of the two, and that's fine in and of itself, but it really is a very thin wrapper around an API. And when you start getting errors or mistakes in your code, sometimes what you get back is an error from an API that doesn't really tell you what the issue is. You've got to look into the problem, maybe stick a proxy between it and see what the actual API payload is to find out why it's failing. So for that reason, many people prefer to use Terraform. Terraform is multi-platform, it's free to use, it's largely open source. If you do need support, there is an enterprise version available. HashiCorp will look after you. But more importantly, it's so, if you're in a consulting organization like us, where we work on Amazon, we work on Azure, we work on Google, having a single tool that can leverage all of those is something that is we desire. So when you work with professional services or Google, you're going to find that most people are actually using Terraform because that's what they know, and it's widely supported. Everything that you're going to do, all the examples that you find on the web from Google, there are as many Terraform examples as there are deployment manager examples, and they try to maintain parity between them as much as possible. So one of the things we'll talk about a little bit further down the line is something called a project factory. We were working with that when it was still an internal project, and we knew that there was 2 teams of people working on it to make sure that when it was released, there would be feature parity between Terraform and a native tool at the same time. So Google recognizes that maybe you want a choice when it comes to that. So, I think I probably just said this. As far as I'm concerned, we're using Terraform. Not that my voice holds much weight, but it holds some weight within our organization. So I'm saying that this is the way we're working. We are now standardized on Terraform. Everyone who's doing infrastructure work, such as my friend Anant here, is learning Terraform. Anyone who's in the cloud infrastructure services team is going to become an expert on it. They're also going to have their own native tools. We'll still have people who do deployment manager. We'll still have people who do CloudFormation. But Terraform is the product of choice when putting together infrastructure as code. Has everyone used Terraform? No? Okay.
Look at our code, we have Terraform somewhere, but I don't know what we do.
Yeah, you definitely do. I know. We'll talk about that later. So
before going to demo, one of the things that the reason we looked at, the Terraform is also like the most powerful of some of the DevOps tools that they talk about there. They talk about some of the DevOps tools, but they're not true DevOps tools. They are kind of pseudo DevOps tool that does some stuff for DevOps and some doesn't do a few things. Whereas if you want to do everything in infrastructure from scratch, Terraform is the way to go. And Terraform gives you support to do the entire infrastructure, including building out your hybrid cloud. So they have even support for hybrid cloud.
Yeah, you
Cloud Armor, and they have support for almost every new product of Google that's coming out there in the infrastructure space is being supported in one form or the other. They're probably about a version behind. So
yeah, probably. That's an important point. Yeah, given that Terraform is open source, anything that's not being done by HashiCorp is being done by Google. So Google have their own GitHub repository of modules that build on top of Terraform, and the official Terraform Google plugin is also being maintained by Google engineers. So it's not very far behind. I don't even know if it's a full version behind, but pretty much everything that comes out on Google, there will be a corresponding Terraform piece very shortly after it's released, if not the day of release.
And then it's like Terraform is also based on a provider model. If you will look at the architecture, it's just a provider model. It provides all the hooks into whatever you want to deploy onto, and so now the support there is the support for a lot of things, including Google Cloud. So I think the support is growing by leaps and bounds. That's because of the provider model, and so every cloud provider or every provider that wants to play in the IOC infrastructure as code space can actually create providers and provide for the coding through Terraform. So that's just something that Google shared with us when they kind of asked us. They were talking about why they use Terraform.
More time, maybe we've done a hybrid demo, but
I think I will take that one.
Yeah, we'll do an advance for another. Oh.
I'll do that. Yeah.
Fantastic. Okay.
Yes.
So let's take a look at some code then. So this is an example of a Terraform project file. It's pretty straightforward. I mean, hopefully that comes through. All you're doing is saying, who's my provider for this particular resource? In this case, I'm doing Google. It could also be Amazon. It could also be DigitalOcean, right? God knows. There's tons of providers that are out there for it. And what I'm declaring here is essentially a VM that's going to run a web server, right? So skip around a little bit, but I've got a compute instance here. I'm calling web. I'm telling it what kind of machine type it's going to be. It's a standard one. I'm telling it what startup script to run when it executes, and there should be a file here for that. Where is it? I'm not check that in. That would be bad. Oh no, there it is. So it's just a very simple little script that makes sure Nginx is installed, and there's a dummy index file there that we can see and make sure it's all executing correctly. But the whole point is here, I'm not really telling it where to, I'm not issuing G-Cloud commands here. I'm not going into the UI to do this. I'm just going to execute Terraform and tell it to go ahead and make this project. Now, one of the things it does is it has the ability to take variables. So variables are, much like the inputs to a function when you're programming. You're saying what the input is. Maybe it has a default value, maybe it doesn't. But these are all things that then can be used throughout the rest of the configuration. Instead of hard coding something, you just got one place to do it. And when you're executing it, you can override it from the command line. You can write a file that maybe you don't check into source control that overrides. But the whole idea is that you can have an infrastructure set up that can be extended, overridden as needed for, classic examples, a prod environment, a sandbox environment, local developer testing environments, whatever it may be. And you can override these just by using different values for the variables. So coming back here, one of the things I do is I'm going to create a compute instance, very straightforward. I'm going to create an instance group, an unmanaged instance group in this case, because we're not going to do any scaling or anything clever there. I'm going to set up an instance group and check, which allows us to put a load balancer in front of it. So all of these things are the, if you've used from the command line, these all map pretty cloud command. In the UI, these are all the checkboxes and in there. But the power, I guess, of this is that there is the ability to avoid hard coding and to use references that itself are generated by Terraform. So one of the things here, when I'm creating this backend service, which is the part of the load balancer configuration, I need to tell it what protocol it's using. I also need to tell it what does it forward this traffic onto. So the backend is defined as a group of instances through a manager. So we're setting up this unmanaged. If I was doing this on G-Cloud command group from one command and use that as the input for another command, right? But instead of doing that here, what I use is a value which Terraform knows. It's somewhat like an object-oriented. So get me the Google Compute instance group named web and give me that unique, fully qualified URL that uniquely identifies this in GCP. So I'll do that myself as Terraform is evaluating this file and creating these instances and all these various resources. It will manage those associations and get the values for me. So if I do change this instance group later, I don't necessarily need to change my backend. As long as it's referring to that same group, no matter what changes I make, the backend. Why that's important, at least point of view, is although we're kind of doing mutability right there, we're certainly going down the path of it. It allows changes when necessary. And when things aren't changing, it's not going to destroy them. So if I change a parameter about the health check, let's say I make it check more often, less often, be more tolerant of errors, It's not going to go ahead and recreate all the instances. It's not going to kill my machines. It's not going to do any of that. It will just change that one piece that's necessary. And if I'm doing fully immutable, it would just be a brand new infrastructure with a different project, let's say.
I think Terraform calls that interpolation.
It is interpolation, exactly. Interpolation is the function of getting the unique value or a combination of unique values from the state file. So let me go ahead and make sure this is nice and clean first. Like it is. Right. All right. So to actually apply this file and make it create the instances I need, it's just a couple of steps. I do a Terraform init, which does some sanity checks on the file, but more importantly, it makes sure that all the providers that you saw there were put into place for this particular project. So it's downloaded the Google provider from the web. It's downloaded the local one. There isn't anything else in here, so there's other ones. But if I was working with Amazon, if I was working with other projects, you'd see those come in as well. So now that it's all in place, there's a new file called .terraform, which is maintaining that local state. I can then do a Terraform plan. This isn't strictly speaking necessary, but one of the things it does, and this is where it gets more important as you start using this in a production environment, is it takes a look at the state file that's local, it takes a look at what's actually out there in Google, in GCP, and it computes what the changes actually will be. So it's telling me if I was to execute the apply, it's going to make 9 changes. It's going to create 9 new resources. It's not going to change anything. It's not going to destroy anything.
Is that computed? That's not changing the computer.
It's not changing anything at this point. Plan just looks at any files that you've got locally. Make sure that it would go through any changes that you made to the files, look at what that might do for your remote system, and then try and merge the two together. If there's a difference, that's what it's going to do. So one of the things you can do, again, in a production environment where maybe you're trying to be very, very controlled, Terraform plan does support something called the out parameter. So I can do -out.
So if you're a DevOps guy, where would you kind of run this part of your? Because you have your GCP cluster, right?
Yeah.
And you might have like a Bastion node or something like this.
You could create like a server where you could install Terraform, but then the state files you could maintain it in a common repository, right?
Yeah. So definitely jumping ahead, not ahead in the demo, but kind of you going deeper into it. What we typically recommend is you have a project and service accounts that are designed just for Terraform or your infrastructure as a tool platform of choice, right?
Okay.
So it's a project that you bootstrap before you're doing anything else that creates a service account that has the right permissions within your organization to create other projects. And then what you do is you run all the execution of files. Whenever they get updated, you run it through that service account and it manages everything in your environment. The idea being that you don't want to stay on your laptop and then I check out the code and make a change and I'm obliterating your changes because I see that 5 instances are going to be destroyed. Remote state works around some of that problem. Actually hasn't done it yet. Let me just do an apply here. It's easier. Easier to show if I do this. This is actually making the change. And what I'll do is, while it's doing that, let me bring up another terminal and take a look. So, let's see if I can. I don't know how well that shows up, but see this file here called terraform.tfstate? That is the file that is local to my machine because I'm running a very simple instance here that says this is what I expect the state to be. If I've got one version of that file and you've got another, we've got a problem, right? We're working on a production system. So the idea is to take that power away from you or I and to centralize it on a gets to do a checkout, clean the checkout, and everything else that we would do. And that's the project factory we're going to talk about later. But this idea that you have a unique project with special permissions, it's almost like a super admin, but that's all it does is create projects, modify projects, and then we give you and me and other admins or other people who have the right to update the system, we give ourselves the right to execute as that. So we can do an IAM binding that says that Means is allowed to execute as that special Terraform service account.
Okay.
So I can instantiate it, I can launch it, but it's running in its own little sandbox and it's got full control over everything. Okay. And if I get hit by a bus, nothing, life goes on, right? Rather than someone trying to crack the encryption on a laptop.
So it'd be like an EC2 instance.
Yeah. So that is actually one of the few advantages of Deployment Manager. Deployment Manager being a built-in service, as long as you've got a service account in a project somewhere, there is a back-end managed service that can execute as that and do it for you. With Terraform, you'd set up a VM. So there's a VM that runs under that service account, has the rights to pull from Git or whatever you're using, and then execute the changes.
Okay.
Yeah. And somewhere in between is most organizations, which is there's a VM, and you and I have SSH keys that let us get onto it. So everything's still in one box, hopefully backed up regularly, but it's still one box that we both have access to, and we make sure that none of us are on the system at the same time. That kind of thing. There's a maturity. One extreme is a lot more complex to set up, but pays dividends. So knowing who I know is working on your project, I know that's the way they're going, because an environment like yours needs highly regulated applications of state changes, right? So something like a project factory with a special service account with very limited access is what you're going to need to get through regulatory auditing and things like that.
So like one person that would have access to this account, or a couple,
one group. Yes, it's one of those things that only a handful of people have. Now, you could have, when you combine it with IAM, which we're definitely going to wait today's discussion, but I love it. We can do it so that the same Terraform service account, you might be able to bind to underneath a development folder.
Okay.
Right? So having projects under folders is something you can do in Google.
I'm glad I'm not developing.
It gets very hairy. But if you had a folder for development, a folder for production, you can have different bindings. So you might be able to attach as that service account in dev, but not in prod. But another two people could. But now it's still the same service account, still the same shared infrastructure. You're just limiting your access to it rather than its access to the changes. Okay. That makes sense. This is above the Terraform. Nice. Let's see if it itself. No, you didn't see that. Because this was working. Let's see. Trying to create things. No code here. On this account, we are all good. Any changes, it seems. Good. We make sure these instances are actually killed. This is part of the problem. I was trying to do something. Now I need to clean up. I did, but the state was out of sync, so I didn't know about these instances because I broke my own rule.
Okay.
Yeah. Come on.
We are ahead of ourselves there. Huh?
Yeah. Live by your own rule.
Bye.
Don't. Oh, come on, I don't want to delete. Okay, so no VM instances, we still got this. Oh, right. This is the other reason why Infra-as-code is good, because it doesn't forget to clean up pieces. Yeah.
I'm just not.
So under run a VM, which you run that VM not using a compute service account, you do one specially. So let me show you an example. Go into Beam Sandbox. Let's see. Take a look here, and I look at. Oops, not that one. I am. Right, we get certain service accounts that get created by default. Right, this, for example, that very first one, it's given the editor role. It can do a lot of things. Maybe that it doesn't need to do, but it's limited to this project and can only do things within this project. If I look at as a special account, I created a unique service account for Terraform right here. So even though it's tied to this particular project, it's called Terraform. Bear with me. Still that same service. So even though this is a project level service account, so by service account and then giving it rights at the point in my hierarchy where I want it to have an influence, I'm deliberately choosing root here. We're able, anything that runs as that service account has special privileges. So if I create a VM that has Terraform on it, and that VM is running with this service account, it effectively has the rights to create projects, to modify them, to do whatever. So, you know, irrespective of who's logging into that box, if it's executing, it's able to do it.
Okay.
As long as we got the credentials there, which is, you know, part of the setup, we just make sure that it's there. Right, so, yeah. Okay, we get back to what we were trying to do.
And then only a certain subset of admins could control the Terraform project itself, right?
That's the plan. Yeah, you'd say those that are able to, depending on how you're enforcing it, those that are allowed to SSH into the instance, or those that are allowed to bind to that particular service account through their own. So even from the command line here, you can impersonate, right, if you've got the credentials, if you've got the right attributes.
Okay.
But the point is you know, instead of Matthew owning the project, Terraform owns the project. Right, exactly. And so I might have privileges within the project, but they're not necessarily owner level. And so the whole point being, you know, something happens to me, we're not locked out.
Okay.
Other people can change what needs to be without having a massive group that covers everybody who might need to do something, right? You can control it at the binding level.
Terraform. I mean, someone hits.
Oh, absolutely. I mean, at some point there's a trust
Yeah.
trust issue, right? Should I be allowed to make the changes is one thing. Assuming I can, am I trustworthy to make those changes is something else.
Yeah.
So that's that. Maybe it's the Wi-Fi in here. It's pretty bad.
And the guest or
No, I do the full one.
much. I think in part we've had a lot of meetings here recently though, like the ones today where everyone's on the Wi-Fi. I think that might slowly start to bring it down to the maybe the regular one.
Instance for you. Yeah.
Yeah, I would. And then I would do short-lived. So for this, where's the manager rules and where it just becomes regular deployment. And that might be